Hello and good afternoon, friends. Welcome to the CEC-UGC live lecture. Dear friends, as you know that we have been talking a lot on big data. We try to understand about the various concepts on big data. We try to understand how big data works, why it becomes mandatory for storing such big data sometimes, which we feel like that this data where to store. So, dear friends, continuing our lectures further on the series Big Data, I would like to tell you all that today we are going to talk further on Hadoop, the software used for storing big data, which we have talked earlier also. We tried to understand about how structurization of software Hadoop is done. Today we are going to talk specifically on the utility of the software Hadoop, as well as definitely, if time will permit, we would be going to talk on another kind of softwares too. And dear friends, for this very discussion on big data, we have again with us in our studios Dr. U.S. Pandey. Dr. U.S. Pandey is Associate Professor in Department of Computer Sciences, School of Open Learning, University of Delhi. Dr. Pandey has immense experience not only in India but in foreign land too. He keeps on sharing knowledge with the students, with the experts, with the professionals. So without wasting any time, I would like to welcome our guest, Dr. U.S. Pandey. Dr. Pandey, welcome to the EduSet lecture.
Okay, thank you. We are talking about the Hadoop earlier in the previous lectures also. Still at the moment, we'll just start, as you are already aware that the big data concept, which is very much in use, a large amount of data, how it is going to be stored, processed and maintained, each and everything like that. Then Hadoop is the another way how these things are going to be handled. So in the same sequence, we are talking how Hadoop is in the wild. Now, as we have discussed earlier also, the system's requirement for the Hadoop in wild is high write-through output. You can see here that the cheap elasticity and storage, the low latency. You can imagine that how this Hadoop is going to be helpful in this kind of environment. Another thing is that in the same way, you can see that it's a high consistency within a single data center good enough. The disk efficient, sequential and random read performance. The Hadoop, which is going to be used very much in these cases where a real time activity is required, a large volume of data need to be processed in time and you need to process the data as you required and you need a result instantly. So in this way, all these kind of things are very helpful. Here again we are talking about the classic alternatives of this. These requirements typically met using large MySQL cluster and catching tiers using Memcached. Contents on the HDFS, that is the Hadoop data file system, could be loaded into MySQL or Memcached if needed by web tier. As we have discussed, these are going to be the alternatives. How the information can be received easily, how the information can be processed easily, how the information can be retrieved easily and how the things can be seen easily. As you are already knowing, in the different kind of, in the virtual kind of activity, take an example when you are running on any social sites where the instant activities are going on. You just write down something, you want to get the response immediately or some kind of questions you have just put for the other respondents and immediately you want to get all kind of responses. Imagine how fast these activities are taking place. Sometimes many number of participants are participating in these activities. You need to process all of them and immediately you want the result to be processed. Imagine how fast it can be done and what are the procedures can be adopted so that these information, these data is going to be processed very much in time, and that too having very much accuracy. Maybe sometimes much more parameters are affiliated to that, and you are taking all those parameters also into the consideration. Imagine it could be in a talking terms very easy, but when you are doing this kind of processing, it may require a huge processing environment and a huge number of data, and without the help of big data, it is not very easy to do all this kind of activity. Now you can see the another problem with previous solutions. As we have discussed, MySQL has low random write through output, big problem for messaging. Here you can see it's a difficult to scale MySQL cluster rapidly while maintaining performance. MySQL clusters have high management overhead. It requires more expensive hardware. As we have just discussed, these kind of difficulties were there, and these kind of the previous solutions were there. It is very difficult to scale MySQL cluster rapidly. As we have mentioned, while maintaining the performance also. The MySQL cluster, as we have just discussed, have high management overhead, and that is why it requires more expensive hardware. Imagine what I mean to say, that utilizing the different kind of hardware, that too using the software and getting a solution. If you are going to get a better solution, sometimes you may require a costly hardware. But how these things can be managed within those resources which you are having with system. So these are the another kind of examples are going to be there. Now you can understand another example we are taking. Take example of a Facebook solution. Here you can see if you add the Hadoop plus HBase as a foundations, the Hadoop software plus this HBase is going to be taken as a foundation. Another improve and adopt HDFS and HBase to scale to Facebook workload and operational considerations. The major concern was availability. Name node in SPOF and failure times are at least 20 minutes. As we have just said, that there are a lot of things how the activities can be improved. If you add all those things, then it can be make as improved foundation in that way. The HBase to scale the Facebook's workload and operational consideration. As we have just discussed, if things are not there, then it may take much more time to respond, much more time to do the activities. Here another kind of things you can see Hadoop in wild, proprietary in author node, eliminates SPOF, makes HDFS file safe to deploy within 24/7 uptime requirement. The performance improvements for real-time workload, RPC timeout, rather fail fast and try a different data node. So you can see how Hadoop is in the wild. What is a Map+Reduce? Origin from Google, OSTI 04, a simple programming model, functional model for large scale data processing, the Map+Reduce is being used to exploit the large set of commodity computers. It executes processes in distributed manner. And the very important thing is that it offers high availability. We have discussed earlier about the Map+Reduce. Now, as we have just discussed, is this large set of commodity computers, and the very important thing is that the processes in distributed manner. In other words, your jobs are going to be distributed, your activities are going to be distributed, the different kind of analytics where you are going or the activities you are going to be there, it is going to be calculated or performed in a distributed manner, and that is why it takes less time. And as we have mentioned, it offers the high availability, and that is why the speed, the processing is going to be very fast, as well as very accurate also. Does not mean very fast that you are going to get the wrong results. Uptime, you are going to get the actual accurate results are going to be there, very high performance activities are going to be there, and because it work in a distributed manner. Motivation, lots of demand for very large scale data processing. Why all those things? You are already knowing that the lots of demands are going to be there for very large scale of data processing. A certain common themes for these demands. Lots of machine needed and a form of scaling as we call. Two basic operations on the input, that is map and reduce. As we have just discussed, in the large, not only in the different kind of social sites at the different environment, these very large scale of data is required. We have discussed about the different application. It could be in the area of health, it could be in the area of environment, it could be any area of the government services to be provided to the all citizens. Not only this, every part of the life where nowadays a very large amount of data is required. And as you know, the data is going to be coming in different form. These kind of things are being multiplied number of times. Imagine if you are getting some information not in the form of text only, you are getting not only in the form of audio only, you are not getting the things are only as a pictorial form, you are getting things as a video also, and sometimes as a real time processing. In other words, all different kind of data sets are available to you. Take an example, if you are going to get a ticket in the railways, earlier when you are getting a reservation, you have to take this much time to get the reservation. If the facility is available that you can get the reservation even the on time or in the train itself, sometimes in the moving train, sometimes using the other kind of activity. It is like that, that all kind of activity is in the real time. In the second way, as utilizing the robotics or other kind of information, you may getting lot of information. Maybe knowing, recently have you seen the different kind of war activity in the entire world, you can see on the TV also. What do you mean by that? The meaning by that even when the war is taking place, they are recording each and every individual activity, how the things are happening. So, what I mean to say, in other words, that even all the videos are the data which you are getting, each and every set of information is going to be stored. And the moment you are storing all those kind of information, And imagine when you are doing the processing, the all different sets of data, and when you are accessing those data, the volume is definitely going to be very large. And it is not the only storing of data. The important thing is that when in the real way these data is going to be used. The moment you required a particular instance, you require the same set of data, or you are calculating based on that kind of requirement. Same way you can take the example in the different part of environment. You have seen recently the examples of many countries where the problem is of the smog, the problem of earthquake, the problem of tsunami or other kind of activities, rainfall, drought or anything you can take it. What I mean to say that the calculation of a very large amount of data, do the analytical processing, and as well as you have to provide the proper result based on the analysis which you are making. Only then you can make the accurate prediction. Maybe you have seen now a lot of things have changed entirely. Earlier, when Mausam Bhavan used to say something, some kind of announcement, people used to take those kind of announcement in different way. But now they have to believe it. Why? Because all those kind of productions are made on the basis of the large amount of data which have been getting through the satellites by high computing environment, different models which have been done for that, and that is why you are able to predict this kind of accurate prediction in that environment. What I mean to say, the same thing, the same kind of motivations is going to be there in every field of life. You are going on a road, maybe you are able to see in your car itself which kind of traffic is there, what is the volume of number of cars are flowing in which road, each and everything you can see lively on your TV, which you can see even now also. But there are different kind of applications which is going to be there, and still at the moment people are using it. You may be already knowing that when you use the different kind of applications which are available on your mobile through the Google, or it could be any other kind of application, when you are moving to a particular direction, you need not to ask anybody about the destination. Put the destination in your mobile, automatically you can set the direction where you have to move through the cars. Not only this, if there is some kind of problem, or in other words some kind of congestion is on the road, that also it reflects to your mobile system that this road is congested at the moment. What in other words I mean to say by discussing all these things? That a large amount of data which you are getting through the different sources is being calculated, and immediately you are getting all these kind of results. Imagine you are at the moment traveling in Delhi, somebody is traveling in Mumbai, somebody is there in Chennai, or somebody is in any other part of the world. Everywhere this kind of application can be used. You can just imagine how the large amount of data is being processed and everything is in order. Even if you are going to a small town, if you set the target, automatically that application generate where you are going to go, which is the right path to reach there. So it is very easy just to see when you see this kind of application that you are getting this kind of help through the computerized system. If you see the backside, how these a large volume of data is being calculated, manipulated, and after doing the processing, you are using that kind of application. So this is a one small example. Same kind of examples can be set in other areas also. it could be the area of e-governance, it could be the area of your mobile governance, it could be the area of e-learning or the mobile learning where a large volume of data is available onto the system also. There are many good books, rare books are available which you can't see physically, those books are there. That is true in a more digitalized form. Even in the India also, rarest book have been fully digitalized and now it is available to you. What I mean to say by utilizing all those things, a very, very large amount of data is available till now. What will happen tomorrow when the all set of information is being collected and then those information is being used? If you just talk about in the area of e-learning, if you take example that if the 3 lakh books are there which you can access easily at the moment, tomorrow if the thousands books are going to be there, many lakhs number of books are going to be there, and then you are accessing a particular content which you are looking for, it will search the content, it will provide you the content. What I mean to say that it will do the processing, required processing for you, and it will come up with the latest thing, come up with the required thing in front of you. So, meaning by that every time the volume of data is increasing like anything, and the only solution at the moment which you are coming through the big data, that you can access these things, the data, you can store these kind of data, you can process these kind of data, and the things which you are discussing, these things motivate us to do something more in this particular direction. And that is why we are coming here, that the basic operations in the form of input is map and reduce. Now you can see here the distributed graph, very big data, split data in different part, and then grip is going to be there, then matches. You can see here how the things are going to be happen, and then get the all matches. So this is how the distributed grip is going to be there, very large amount of data which is going to be split in different way, and then its grip matches and get all the matches. Again, the distributed word count. For example, again it is a very big data, the data is being splitted in a different form, and the count is also splitted in that way. So you can just do the counting in this way, and then merge, count. So what I mean to say is here, the very big data which have been splitted in a different parts, again being counted separately, and then put it, merge all of them, you will get the required result. The objective, as we have discussed, that these kind of activities are being done in a distributed environment, and this is the main benefit. The one task which have been divided in different small tasks, after completing each and everything have been put together, and you can get your required result. Here you can see the Map+Reduce, very big data. After doing as you have done earlier all those kind of, it's map, and finally it have been reduced, and you are going to get the result. That was the objective, plus map plus reduce. Your each and every task activity have been performed, and after this it have been reduced, and you are going to get the result in that way. Now here you can see the map accepts input, key, value pair, and emits intermediate key value pair. And the reduce, what is it? It accepts intermediate key value pair and then finally emits output key value pair. So, this is how map and reduce going to be there. As again I am putting a large amount of data, your big data is being here put in a map. In other words, it accepts your input and then emits intermediate key and value pair, and lastly then it reduce. The results are going to be, they accepted the intermediate key value pair and emits output value. Here you can see how the partitions functions are going to be there. Now, we just talk about the architecture overview of this. As you know, here the user used the job tracker and then slave 1 node, slave 2 node and slave n different number of nodes where the things are going to be there. These are divided in different task trackers. And then different kind of activities are taking place. So, this is how the structural overview, you can call architecture overview of this. The master node, it divides the whole job in different kind of nodes, maybe 1, 2, 3 or up to n. And then different nodes will do the different task tracking activity and then it will return back. Now, we talk about the GFS, the underlying storage system. What is the goal for this? The global view. It makes huge files available in the face of node failures. And as we have just discussed about the master node, that is meta server, which is centralized, index all chunks on data servers. So, this is how the things are going to be. Now, what is this chunk server? That is a data server. The file is split into contiguous chunks, typically 16 to 64 megabyte, and each chunk replicated usually 2x or 3x, and as we say, try to keep replicas in different racks. This is, we are talking how the data is being split into different continuous chunks and how these things are being stored, and later on we will see how these things are being used. So, as we have mentioned, we try to keep these replicas in different racks. You can see here a GFS architecture. This is the GFS master. You can see here the C1, C0 and different kind of chunk servers. One, again the same master is being connected to chunk server 2, and different kind of chunk servers are going to be there, and ultimately it is connected to your this client. So, this is how the GFS architecture is being run. Different kind of data sets which have been put it in a different racks, and this is the way how it start functioning. you can see the functions in the model. As we have just discussed, how the different kind of set of information, set of data is going to be put in different chunk servers. And now these need to be processed, and then ultimately you are able to get the real result very much in time. You can see here the functions in the model, as we discuss about the map, processes a key value pair to generate intermediate key value pairs. And after that, the reduce merge all intermediate values associated with the same key. As just to get the result, all these things, all the values, intermediate values you are getting is going to merged, and after finally you will get that kind of result which you require. And again, by partition, by default hash key mod OR, you can see here a well balanced. So you can check and you can get the required result. Now you can see here how in diagram 1 all the different type of data is going to be computed in different cluster. Is DFS block 1, DFS block 2, DFS block 3 and all, and then you can see all these blocks are being mapped at different blocks, and after mapping all these things, it is linked to reduce a very large amount. You can see here in the diagram a very large amount of data which have been putting in a different blocks, or in other word you can call is going to be distributed in different places, the different clusters, and after doing the mapping of all, it is being reduced, and ultimately you are going to get the result, required result what you want after processing. So this is, you can see how a very large amount of data is being processed very much in time and try to provide you the required result. Now the very important thing which I would like to mention again to all of you, it is not only the textual information, it is not only the numerical values. This kind of data is containing a different kind of type. It could be, as we mentioned, it could be a text also, it could be a video also, it could be any form of data as you may require, as you know at the moment. Take a very simple example. Sometimes when you are searching on web, sometimes you want to search a particular person name by seeing a picture, by seeing a video. You would like to search a particular professor's name linked with a particular lecture, linked a particular topic. What I mean to say that you are not searching just by one activity. You can link with many things. In other words, the data, it could be related through a numeric value, some textual value, some different kind of characteristics, or you can say it could be a picture also, it could be a linked video also, or anything like that. So these things are being processing of these kind of data is really a tough task, and the very important thing is that you need to get result very much in time. So that is why this kind of processing is required. Now you can see another diagram where this kind of task have been put in a different way. You see the parallel execution, how fast you are going to get these kind of results. You see map task 1, map task 2, map task 3, and you see here that the different tasks individually are being mapped, and after doing that, partitioning functions which is coming out from all of them, then sort and group, all of them sort and group, and that it will say, you can see reduce task, as we have given here K1, K2 and different kind of map task 1, task 2, K3, K4, K5, all these are being there here mapped, and after doing you can just put like this, reduce the task in this form. In other words, what I mean to say, the parallel execution is taking place. The same kind of activity, the same kind of execution, the way of calculation is being parallel. This is the way how you can get the fast and accurate result. Not only this, you can run a very tough kind of applications using this kind of activities. Now, you can just see here a very simple program you can see. Take an example of counting words in a large set of documents. Very simple to say, but what we are doing is here in the case of mapping, string values have been given, all the document we are going to be there. The key is the document name, the value is document contents. If we are counting for each word W in value, the intermediate W, that is 1. Now, if this is going to be taken as a map, then what will happen to the reduce? The string key, the interpreter value which we are getting, the key is here word. Remember, earlier the key was a document name, but here the key is the word which you are getting after that. The values is the list of counts, and here you install that in result is equal to 0. For each V in values, result the symbol plus equal to is equal to parse into V. Ultimately emit as a string result. What I mean to say, just by execution of the simple program, you may be able to get in the large amount. Now, here you can see how it works. You can see here the functions, how it works. Split all the things in a different form, 0, 1, 2, 3, 4. Different workers have been done. For a 0, 1 worker, for 2 another worker, the different read and all. And then you can see here the user program 1, 4, 2, 3 and all. After the master assign all this, you can see the remote read the intermediate file on local disk, and ultimately it will go again to the last that we have given as the workers, and then lastly you can see it is a reduce phase. Earlier the activity which you are performing is in the map phase, and ultimately after doing all sort of activity for doing this, you do on the reduce phase, and then you are going to get output files. Again, it is the same way of functioning as we have just discussed. The larger task, the larger activity is going to be divided into a smaller task, and after getting the result from these smaller tasks, all the results using the reduce is being put together. In other words, you can say merged, and then ultimately you are going to get your results. So, the big data concept already you have understand the activities which are being distributed, and after doing those distributed activity parallelly, you are able to get results very much in time accurately, and you can process a very large amount of data, you can say data processing. Now, locality issue, the very important issue is related with that. Master scheduling policy. Ask GFS for locations of replicas of input file blocks. Map task typically, as we have just mentioned, is split into 64 megabyte, or it could be the GFS block size, are in the same sequence. Map tasks scheduled to GFS input block replica are on same machine or same rack. If is effect, what is going to be the effect of that? The thousands of machines read input at a local disk speed. Imagine large amount of data you can just get collected. Without this, rack switches limit read rate. So, in the locality issue, as we have discussed, that is the master scheduling policy, how the different set of data is being racked, how these are being categorized, how these things are being stored, and then how these things are being used for calculation for doing different activity. And what effect is going to be there? Again, we are putting that how you can grab a large amount of data. Very simple example, again I am putting, you will be knowing that you are using social sites. Take example, thousands people, if I put thousand, it may be more lakhs or crores of peoples are working together, and a very large amount of data. I am putting the word very, very specifically. What the meaning of very is here, you are not using text, again I am repeating. Sometimes you are sending the whole movie, sometimes you are sending the set of videos, sometimes you are sharing large volume of data, sometimes you are sharing a full lecture, and each and everything you have just loaded. This is a one person activity. Simultaneously, you are getting lot of information from other sources. You are interacting, and immediately after loading those information, you start getting the responses. What I mean to say, these things have been uploaded and it has reached to the persons very quickly. You have start getting response very quickly, and everything is happening real. What the purpose is that a very large amount of data which have been stored somewhere, which have been done some kind of processing as required, and immediately if you need some kind of responses, that also you are getting. Imagine how fast these activities are being done. As a user, it's look very easy. Sometimes when you are getting a response little bit late, you get irritated. Maybe you are working on Facebook, you are working on Twitter, maybe you are working on any different kind of social sites. Not only this, even you are having any kind of chatting, the informations and all. What I mean to say, that immediately getting response from so many users, the receiving data from large people, processing them, storing them, calculating them, and then go up to the results. These processes are very complicated, which you have just seen. Now, another very important thing is fault tolerance. You can see here the reactive way. Worker failure, heartbeat. Workers are periodically pinged by master, no response, that is equal to failed worker. If the processor of a worker fails, the task of that worker are reassigned to another worker. Just imagine this kind of fault tolerance activities which are programmed in such a way that if one task which have been assigned to was task tracker, or in other way a worker which are doing the job are to the one segment who is supposed to calculate your part and give to us. If there is some kind of problem is persisting, immediately that task is going to hand over to someone else, or some other task manager, or some other worker. They will assign, and quickly you are going to get back all those kind of information. Imagine this kind of fault tolerance activities are going to be there. The next job is going to be reassigned to someone who will compute and give it back to you. As we mentioned, if the problem is persisting, even the second assignment, it may go to any third person to put the things and to get the required result in time. Another way you can say master failure in the fault tolerance. If the master writes periodic checkpoints, another master can be started from the last checkpointed state. If eventually the master dies, the job will be aborted. As we have just discussed, even not only in between, in the beginning also, if you are getting some kind of major problem, if it is able to be repairable, this whole process can restart. The whole process can be done again and again to provide you the best result, to provide you the accurate result, to provide you the real time result in time. Now, another thing you can see in the fault tolerance is proactive way, that is redundant execution. The problem of stragglers, that is the slow workers, other jobs consuming resources on machine, bad disk with the soft errors transfer data very slowly. Wired thing, the processor catches disabled. We have just talked about the different kind of fault tolerance. Here again, as we just mentioned, that if activity which is being performed is slow on the particular machine, or the particular worker is not working up to the mark, there are different way to take how this kind of execution can be put on right path. So, in the this kind of fault tolerance, proactive ways are also being there to put each and everything in order. Another thing, when this computation almost done, reschedule in progress task. If required, as we have just mentioned, that if any kind of slow activity is taking place, some kind of calculation is not up to the mark, some kind of problem is coming to the data handling and all, these kind of things are being rescheduled in progress task. whenever the primary or the backup executions finishes, mark it as completed, and that is why these things are being taken care. Now, another fault tolerance where the input error or the bad records are going to be there, the map-reduce functions sometimes fail for a particular input. The best solution is to debug and fix, but not always possible. As we have just mentioned that when you are sometimes when you are entering the value, again we talked about the same thing, because the different types of input are going to be there. So, sometimes there may be a problem to use those kind of values or not getting those value as it is, then definitely there is a problem to do the computation in the map-reduce functions also. As we just mentioned, these values are not only in one form, these values are not only numeric, text, audio, video or anything like that. Sometimes bad pictures have been put as a input, sometimes a bad video have been put into the pictures, sometimes a not good text is there. So, it is very difficult to use sometimes because of not proper input. So, here the best solution as we mentioned is to fix the debug the fix, and which is always not possible. And again on the fault tolerance part, on segment fault, send UDP packet to master from signal handler, include sequence number of record being processed. So, sometimes in the fault tolerance the segment faults are going to be there, where these kind of things the master from signal handler is being there, which include the different number of record being processed. Another fault tolerance, that is skip bad records. If master sees two failures for the same record, the next worker is told to skip the record. As we have just told that in the fault tolerance different kind of activities, here if a master is not able to read the same kind of record, or in other words if you are not getting the correct input 2 or 3 times, then definitely it will skip that particular record and try to say for the new one, try to set things for the new kind of activity. So, this is again that the fault tolerance activities are going to be there. Here you can see that the status monitor, how these things are being seen. You can see here that the map-reduce status, MR indexer beta 6 large 2003 10 28 003, here everything had begun, started say for example Friday November this, the date time up to this kind of thing second. You can see here it 1700 worker 1, this dates and up, all you can see the type, shared, done, active, the input in the form of megabyte, done, and output how much in the form of map. After shuffle and after reduce, you can see the details which have been there. And other side you can see the counters, the variable that is mapped, suffer, you can see the output, document index set, documents indexed, and each and every merged output which you are getting here. So, how this is how the status monitor functions, where you are going to get each and every day status, and here you can see even in the chart also how the reduce, shared and percent completed. So, all the kind of status and these activities are being monitored. We have talked about the fault tolerance also. We have talked about the Hadoop in different wild also, and the very important thing again I am putting all these things because you are going to get different sets of input that is in the form of text also, numeric also, as well as it could be in the form of video also, it could be in any other form. And processing these informations, processing all these kind of data is a tedious task. We discussed about the map and reduce also, how the total number of tasks are going to be divided into different subtasks in a distributed manner. All these kind of tasks are being done, calculated things in a parallel way, and that is why you are going to get very fast and real results. We will talk more about this in the coming lectures. Thank you.
With this note, thank you, sir. Thank you once again for giving us a very vivacious session on big data. I hope that all the students who might have watched us would be benefited from this particular lecture. So, dear friends, if you want to see the other lectures which were conducted in recent past, then also you can access our lectures with the help of YouTube if you have missed earlier through our live streaming. So, on YouTube all the lectures are available, and this lecture also we are going to upload very soon. So, dear friends, if you have any kind of queries or if you want to give your feedback regarding this particular lecture, then you can mail us at info.cc@nic.in. We would be meeting again very soon and would be knowing more and more from Dr. U.S. Pandey. So, Dr. Pandey, once again, thank you for giving your precious time as well as precious inputs to this particular lecture. Thank you, sir.
Thank you.